Our goal in this section is to graph sine and cosine functions. And I'm going to start by graphing, or at least thinking about the graphs of y equals a cosine of x and y equals a sine of x at some very friendly points here. So at points like 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and of course this has two names of 0 and 2 pi. So let's see if we can't fill in this table for the value of the cosine. What's the cosine going to be at pi over 2? Cosine is which coordinate? Your x-coordinate or your y-coordinate? X-coordinate. So what's the cosine of pi over 2? Yeah, this is backwards, isn't it? So 0 there. So yeah, 0 and then 1. So the cosine at pi over 2 is 0. How about the cosine of pi? Negative 1. And then back to 0, and then back up to 1. So we just went around the circle and filled in some easy coordinates for the cosine function. I want you to do the same thing for the sine function. Fill in those values for the sine function. Sine of 0, sine of pi over 2, sine of pi, etc. So Rebecca, what do we get when we look at the sine? What are these values going to be? All right, so 0, 1, 0, negative 1, 0. Is it fairly easy to come up with these values? Are these easy to work with? Okay. Now what's going to happen is that, unfortunately, we're not always going to be given the sine and cosine at these easy points. You're going to be asked to graph stuff that's a little bit more challenging. Stuff, say, for instance, like y equals 3 times the sine of 4x plus pi plus 1. But what I want to do is, with a little bit of work, choose the correct points, and those correct points are going to make it as easy as filling in this chart. Now, the work is going to be up front. We're going to have to be very careful about the values of x that we choose. But if we choose the right values of x, we're going to get this and either the cosine or the sine of that. So let's take a look at our handout. We're going to graph that function I just mentioned right here. Y equals 3 times the sine of 4x plus pi plus 1. And I've given us a little chart here. So let's fill in some things here. Now the idea behind this chart is to kind of organize ourselves a little bit so that we can graph this. I'm not going to start here. I want to start here. With the proper choice of values of x, then what I'll get is this. I'll get 0, pi over 2, pi, 3 pi over 2, and 2 pi. So with the proper choice of x's, when I take 4 times x and then add pi, I'll get this. That's key. You should always get this with your proper set of x's. Always. This is a slam dunk, automatic. What's the sine of that going to be? Well, we're back to the chart we just put down. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi, 0, negative 1, and 0. Let's move to the next column. The next column says I want 3 times that. Can someone read me what's going to be in the next column? Well done. 0, 3. 0, negative 3, and 0. So you're just multiplying this column by 3. How about in the last column? What am I going to get there? 1, 4, 1, negative 2, and 1. All right, so you're just adding 1 to that column, right? Now this last column is going to be your y column. Graphing that's going to be pretty nice. The real work then is going to be coming up with the x's. That's your first column. So how are you going to choose the x's? We want to choose the x's so that this happens. And in order for that to happen, we're going to solve a little inequality. And that little inequality is going to give us our first 2 points. We're going to take this expression here, whatever it is, and set it up between 0 and 2 pi. And that'll help give us our first 2 points. So points 1 and 5, we're going to get by taking 0, set that less than or equal to 4x plus pi. And that's going to be less than 2 pi. And I'm going to have to solve that inequality. I want to solve for x. Well, I guess the first thing I'll do is I'll subtract pi from all 3 parts of the inequality. That gives me negative pi is less than or equal to 4x is less than or equal to what?
0.
No. Pi. Just 1 pi. Now I'm almost done. I've got rid of the pi here, but I need to get rid of the 4. So the last step would be to divide by 4 and get pi, negative pi over 4 is less than or equal to x, and that's less than or equal to pi over 4. And these are points that you're going to use to help graph this. Those are what I call points 1 and 5. You need a total of 5 points to do this method. So 1 and 5. Now the rest of the points that we're going to come up with are going to be midpoints. They're going to be what you get when you average these things. So if I average things, how do I average 2 numbers? What do you do? What's the operation? Excellent. Add them and divide by 2. So if I want to get the third point, I'm going to take negative pi over 2, or excuse me, negative pi over 4 plus pi over 4, add them up and divide by 2. So what's that point going to give me? 0. 0 over 2, or just 0. So I've gotten 3 of my points. I got points 1, 3, and 5. In fact, those are already written down for you up here.
Is that going to be the same always? The second column?
Yes, the second column, if you do this right, should always be this. In fact, if you want, we could check it. Let's check it with, we'll check it with the easy one first. 4 times 0 is 0, plus pi is pi. 4 times negative pi over 4 is going to be negative pi. Negative pi plus pi is 0. If you do it right, these points will always lead to this. Now you can check it. It's up to you. It should be, you should take some care in getting these points. When I grade these problems, if this is a 10-point problem, you get 4 points just for getting your x's correct. It's a big portion of getting this problem right. Now, to find point 2, again, I need a little midpoint. What do you think I'm going to have to average to get, point 2? I'm going to average 1 and 3. So negative pi over 4 plus 0 divided by 2. That's going to be negative pi over 4 divided by 2 over 1. Why did I write it as 2 over 1? Yeah, so I can invert and multiply. If you invert and multiply, negative pi over 4 times 1 over 2 gives me negative pi over 8. So that's point number 2. It's negative pi over 8.
So then for 4 you use 3 and 5.
Yep, for point 4 you use 3 and 5, so it's going to be 0 plus pi over 4 divided by 2. And I think based on our work for the previous one, you can kind of predict what you're going to get here. Pi over 8. So those are our points. So let's see. Pi over 8. Now let me point out a pattern that should be true when you do this work. And it should always be true. When you look at these things, what's a common denominator for all of these points? 8. So I could write pi over 4 is really 2 pi over 8. And this is pi over 8. That's 0 pi over 8. That's negative 1 pi over 8. And that's negative 2 pi over 8. It should just be a nice, even set of points. The distance between each of these points should be the same. So I'm sorry that's a little bit illegible. Let me write that down here on my x-axis. So I've got points at pi over 8, pi over 8, 2 pi over 8, negative pi over 8, and negative 2 pi over 8. And of course 0, but I didn't draw 0. So these are my x-coordinates. Let's put in the y-coordinates. So the y-coordinates, well, we have those over here, correct? So at negative 2 pi over 8, I should be at a height of 1. At negative pi over 8, then I'm at a height of 4. At 0, I'm back down to 1. At pi over 8, I'm down to negative 2. And then at 2 pi over 8, I'm back up to 1. And now I can play connect the dots, because I have one period of this function. Now remember, this is a sine function. Let me come over here for a second. Your graph should look like a sine wave graph. It should be nice and smooth. It shouldn't be like a sawtooth. So if on your test you play connect the dots like this, I'm going to be pretty unhappy. That's not a sine function. All right, your graph should be somewhat smooth. Now I'm not looking for perfection. What I'm looking for is something reasonably smooth. Like I said, it doesn't have to be perfect. So up here, down here, and like that. And there you go. You've got one period of your sine graph. Now, if you got one period, you should be able to extend this to more periods, right? What's the next value of x going along the x-axis? 3 pi over 8, 4 pi over 8, 5 pi over 8. Now, some of these reduce, but you know what? I don't care. I don't care that this is really pi over 2. I'd actually rather see it as 4 pi over 8, because it's easier for you, right? Because it's easy to tell what the next one is. What's the next one here? 6 pi over 8. And what we can do here is extend our graph. So from a height of 1, where's the next y height? 4. All right, let me hear some new voices on this. After the next one, where am I going down to for the next point? Down to 1. Down to negative 2, and then back to 1. So once you have one period, you can extend this as far as you want. So there's the second period. And this is exactly what I'll ask you on the exam, is to draw 2 periods of this graph using the 5-point method. So if you just get the x's and nothing else, I'll give you 4 points out of 10.
Will we be given some of the points?
No, I will not be giving you any of the points. I did that on the handout just to be easy, but no. On the come time for the test, you should be doing that on your own.
Okay.
Yes, sir.
Points 1 and 2 are all going to be negative points all the time?
No, it's going to depend on the argument of your sine function. In this case, it worked out nice like that, but you shouldn't necessarily count on that kind of symmetry. It was just a fortunate one for this example. Appreciate the question. All right, I guess we'll do some next time. So,
Well, thank you.
see ya.